In this question, we are given the derivative of the position function of the particle, that is dr by dt. This is basically the derivative of the position function of the particle. And we have to determine the location of the particle when t equals 3. Using this initial condition, that is r of 0 is given as 10 comma 6 in vector component form. So let's see how to find this position or the location of the particle at t equal to 3. First, I'm going to rewrite this dr by dt as like this. That is, this is basically r prime of t, and this can be written as the position of the derivative of the position function. We can write down this as x prime of t, comma y prime of t. So basically, we have to first identify, or we have to find x of t as well as y of t, which will give the r of t. So first, when you compare these two equations, these two represents the same equation, and this means x prime of t equals this expression, as well as y prime of t equals this expression. So let's write down the expression for x prime of t. We have x prime of t, and this equals 14t minus 9 by t plus 1 quantity square. So this is 14t minus of 9 by t plus 1 quantity square. And we'll identify this y prime of t, and this equals 2t minus 4. This is 2t minus 4. So now using this equation, if we integrate both sides, we will get the r of t. So integration of r prime of t is r of t, and this equals, we will integrate, and then we will get only x of t comma y of t. So it's basically we have to integrate the x prime of t as well as y prime of t, so that we get these two components of these two expressions, x of t and y of t, which will help you to get the r of t. So let's see how to determine this x of t and y of t using the derivative of those functions. So now here we have this x prime of t. I'm going to copy this and we will do the integration, so that we will get x of t. This is 14t minus of 9 by t plus 1 quantity square, and I'm going to integrate both sides. So we will integrate with respect to time. This is also with respect to dt. So on the left side, we will get integration of the derivative function. We will get only the corresponding function, that is x of t, and this equals, we have to integrate term by term. So we first integrate 14t with respect to dt, or with respect to time, and then integration of 9 by t plus 1 quantity squared dt. So let's integrate this. Integration of 14t, we can factor out the 14 out of the integral, and we just have to integrate to t. And similarly, I'm going to factor the 9 out of this, and when you factor that, we will get 9 times of integral of 1 by t plus 1 quantity square. And this 1 by t plus 1, I can rewrite this as t plus 1 raised to the power of minus 2. So here I put integral of t plus 1 raised to the power of minus 2 dt. Now let's integrate this. So this gives 14 times of integral of t is, using the power rule, this will be t raised to the power of 1 plus 1, which is 2, divided by the same number, that is 2, minus 9 times of, here also you can use the power rule. So it will be t plus 1 raised to the power of negative 2 plus 1, divided by negative 2 plus 1. Negative 2 plus 1, and this equals negative 1. So I'm going to put negative 1 here, and also in the denominator, this is also negative 1. And then we put the integration constant c. Here I'm going to represent this as x because we are concerned about this x of t. So let's simplify this. We can cancel this 14 goes into 2 as 7 times. So this is basically 7t square minus of, we have minus and minus, so this will become plus 9 times of t plus 1 raised to the power of negative 1. So this can be written as 9 times of 1 over t plus 1, which I can rewrite this as 9 by t plus 1. And then we have this integration constant cx. So this is basically x of t. Now we will use the initial condition, that is r of 0 is given as 10 comma 6, and this means x of 0, this is 10, and this is y of 0. So let's plug in t equal to 0 here. That is, we are given that x of 0 equals 10. So I'm going to plug in t equal to 0 into this equation, and also x of 0 equals 10. So when you plug in t equal to 0, it becomes x of 0, and this equals, we already know that x of 0 equal to 10. So we will have 10 equals, we plug in t equal to 0 here, becomes 7 times of 0 square plus 9 by 0 plus 1 plus cx. So this one will get cancelled, and 9 by 0 plus 1 is 1. So this is equivalent to just 9 over here. So we have this equation, 10 equals 9 plus cx, integration constant for x of t. That is, this implies cx equals 10 minus 9 is 1. So we have determined the integration constants for the equation x of t. Now we can substitute into this x of t so that we determine x of t. So we have x of t equals 7t squared plus 9 over t plus 1 plus cx, which is 1. So we have determined this x of t. We now determine y of t by integrating this equation. So let's consider this y prime of t equation. That is y prime of t, and this equals 2t minus 4. So integrate both sides. So this will be integration of 2t minus 4 dt. And on the left side, we will get integration of y prime of t. We'll get this y of t function, and this equals, we have to integrate term by term. So it is integral of 2t dt minus integral of 4 dt. So we can factor this 2, and then we have to integrate t, and here also we can factor this 4, and then we'll be left with 1 dt. We know that integral of t is using the power rule. It will be t raised to the power of 1 plus 1 divided by 1 plus 1 when we use the power rule. So it's basically t power 2, that is t squared divided by 2 minus 4 times of integral of 1 dt is t. We then put this integral constant for y of t function, which we put as c of y. So this is y of t. We will simplify this. This 2 gets cancelled, and so we can rewrite this y of t. This equals t square minus 4t plus cy, where cy represents the integration constant for the function y of t. Now we will utilize the initial condition, that is y of 0 equals 6. So let's use that and plug it into this equation. We have y of 0 equals 6. That means at t equal to 0, y of t equals 6. So when we put t equal to 0 here, this becomes y0, and this equals 6. And this equals, we plug in t equal to 0 here. This becomes 0 squared minus 4 times of 0 plus cy. So these two terms gets cancelled because they are 0, and we are left with 6 equals cy. And this implies cy, that is the integral constant for y of t function, is 6. So we can plug this value into the y of t equation, that is into this equation. So therefore we get y of t, this equals t square minus 4t plus 6. So we have determined this y of t equation. So now that we have determined both x of t as well as y of t, we can find the location of the particle at t equal to 3. That is r of 3. We can plug it into this equation. And when we do that, r of 3, this equals x of 3, comma y of 3. And this means we have to determine x of 3 and y of 3, which we will do now. So all that we have to do is we have to plug in t equal to 3 into x of t as plus t equal to 3 into y of t to determine x of 3 as plus y of 3. So let's do that. I'm going to plug in t equal to 3 into x of t. So therefore this becomes x of 3 equals 7 times of 3 squared plus 9 by 3 plus 1 plus 1. So let's simplify this. This equals 7 times of 3 square is 9 plus 9 by 3 plus 1 is 4 plus 1, and this equals 7 times 9 is 63 plus 9 by 4 plus 1. So this is 63 plus 1 is 64 plus 9 by 4. Let's simplify this fraction. Consider this as 64 by 4. So we have the least common denominator as 4. So this 64 by 1 has to be multiplied and divided by 4. And we will keep this 9 by 4 as it is. So therefore this becomes 64 times 4. We'll multiply this. This is 4 times 4 is 16. 6 times 4 is 24. It is 256. So this is basically 256 by 4 plus 9 by 4. So this equals 256 plus 9 equals 265 by 4. Let's now determine y of 3. So I'm going to plug in now t equal to 3 into the y of t equation. So therefore this becomes y of 3, and this equals 3 square minus 4 times of 3 plus 6. So this equals 3 square is 9. 4 times of 3 is 12 plus 6. 9 plus 6 is 15. 15 minus 12 is 3. So y of 3 equals 3. So we have determined both x of 3 as well as y of 3. We can plug it into the x of 3. X of 3 is it is y of r of 3. So when you plug it into r of 3, we have to put x of 3 as well as the y of 3. So therefore, the location of the particle, that is at t equal to 3, this equals r of 3 equals x of 3 comma y of 3. And we have already determined x of 3, that is 265 by 4. This is x of 3, 265 by 4 comma y of 3 we have determined as 3. Let's write this in vector form. So this is 265 by 4. This is I vector plus 3j vector.